we're going to look at is number 2. Again, most people got number 1 correct, but number 2 should have been just as easy a problem, but for some reason we only have 42% get this right. This one says Jane wins $10 if a die roll shows a 6, and she loses $1 otherwise. Okay? So again, with the expected value, we said you're going to list your outcomes, and we'll call that X, and then we're listing the probabilities of X occurring. Okay? And the first outcome is that you would win dollars.
Sorry, thank you. So you get plus $10 if you win, and then you get what if you lose? You lose $1 otherwise. So maybe you're having to pay $1. I don't know.
Yeah.
But that's not how they're setting the problem up. They're just saying you lose $1. Because there's a different way to handle it if you're paying to play, okay? So right here we need, with our outcomes, we need the probability of that outcome happening. And you win $10 if you roll a die and it shows a 6. So what's the probability of rolling a 6 on a 6-sided die?
1 in 6.
Yeah, 1 in 6.
Wait,
And what is the probability of you losing? Well,
5 and 6.
it's 5 out of 6. It's just the complement of that event. 1 minus 1 over 6 is 5 over 6.
Can I show them?
Yeah. Just be careful on it. Just be gentle. It's Loctited to the wall. All right. So, guys, we want to look at the outcome. So, the expected value for this problem is just saying, hey, I could win $10 times the probability 1 over 6, or I could lose $1, so that's going to be a negative $1 times 5 over 6. Okay? And then you simply add that up. Okay? And let me look at what that is. So you have $10 times 1 divided by 6, and then that's plus a negative $1 times 5 over 6. And you end up with an expected value of 0.83. Okay? That would be 83 cents. Is this a fair game?
No, it's positive you win.
Is it fair?
No.
It's not fair. If the expected value were 0, it would be fair. I forgot to mark y'all in the middle. So Jody's not here? All right. But why do that? All right. Does anyone have any questions on that one?
TJ's getting the blood drawn.
Okay. Yeah, I'll get them when they come in. But guys, do y'all realize every single one of these is simply listing the outcome and its associated probability, and calculating expected value is simply taking the product of these two, the outcome times its probability, plus the second outcome times its probability, and adding them together. That's all you're doing. Okay? So all of these should be easy. Okay, the hard part is, can you come up with a probability for the outcome? Okay? And if you can, then you're set, because it's just a product, add them up. Okay? So let's move on to the next one. Let's see what's here. It looks like 3 and 4 were fine. 5 and 6 people missed, but like I said, I kind of want to go with the ones everybody missed. Like, you got question 12A and B here. Nobody got that right. You got question 13. Nobody got that right.
Nobody?
Nobody. It could be someone typed it in wrong. They didn't follow directions, didn't include the $sign, didn't do it in the right format. But I told you guys, if you didn't type it in right, it gets counted wrong. Okay? This one, Q13, 0%. Let's look at question 13 and see. All right. Let me switch pages. This is going to be problem number 13. And let's read the problem. It says a box contains 100 envelopes. 10 envelopes contain $10 each. 10 contain $5 each. 2 are considered unlucky, and the rest are empty. Okay? A player draws an envelope from the box and keeps whatever is in it. If a person draws an unlucky envelope, he must pay $100. So what is the expectation of a person playing this game? Okay? So again, just like last time, the first thing to note is that I have 100 envelopes total. Okay? They tell you 10 have $10 in them. You have, 10 contain $5. And you have 2 that are unlucky. What was unlucky? Do you have to pay $100? Yeah. So you pay $100. And then the rest of them are what? Just empty? So how many are empty? What's 100 minus 22 on your calculator? 78 are going to be empty. Okay? So that's just writing down the info from the problem. Okay, now we want to set it up. We want to, again, look at our outcomes, which is our x, and we want to look at the probability of x occurring. Okay? Alright, so the first outcome could be that I draw a $10 envelope, right? So I could come out $10 ahead. The second outcome is I could draw a $5 envelope. That would be nice too. And then the next one could be that I lose $100 because I have to pay it because I draw the unlucky envelopes. And then the other one is that I get nothing. I don't pay, I don't lose. Okay? So now what is the probability of each of these occurring? Okay? 10 of them have $10, so what's 10 out of 100? What's 10 divided by 100?
1.2.
Okay, 0.1. And this also has 10 envelopes, so that's $5, so that's going to be 0.1. And then here for the $100, that's 2 out of 100. What is that? .02. You just say 2 over 100. And then the other one here is going to be 78 out of 100, which is 0.78. Alright. All of those should add to what? 1. Yeah, all that adds to 1. Alright, so now what's the next step? The expected value is to just simply take each of these outcomes and multiply by its associated probability and then add them up. So you have a $10 times its probability of 0.1. You have $5 times its probability of 0.1. Then you're losing $100 times 0.02, and then 0 times 0.78, which obviously that whole term goes to 0 over here. Okay? So then what is the expected outcome for this game? You just add it up. So you're going to say 10 times 0.1 plus 5 times 0.1 minus 100 times 0.02. Oh. crud, I typed something wrong. It gave me a syntax error. So 10 times 0.1 plus 5 times 0.1 minus 100 times 0.02. And I get like a negative 50 cents. Okay. So basically you're expecting to lose 50 cents. Okay. Is that a fair game? No, because the expected value is not 0. Okay. All right. Does anyone have any questions on that one? At all? Do what? All right. All right. What's the next one? Let's look at number 15. I was looking at that one earlier because that was another one y'all had missed. That one deals with like stocks and whatnot. All right, number 15. 15 says an investor buys 1,000 shares. Okay, so I'm going to write down 1,000 shares of a risky stock for $5 a share. So $5 per share. She estimates that the probability the stock will rise in value to $20 a share. So you're looking at going up to $20 a share. Is what? Is 0.1. And so that's the probability of that happening. And then the probability that it will fall to $1 is equal to what? 0.9. And they're saying if the only criterion for her decision to buy this stock was the expected value of her profit, did she make a wise investment? Okay. Guys, what is profit? How do we define profit?
After expenses and your expenses and your income.
Okay, so it's basically revenue
Yeah.
is your income minus your cost. Okay. So what are my outcomes here? We need outcomes, and we need the probability of those outcomes. So I'm looking at first that her share price goes up to $20 a share. So how much is she gaining? What's her profit? Is her revenue is $20 minus the $5 that she paid, right? Guys, the ones that are sitting and playing on the computer, do y'all mind paying attention? Because, I mean, either one, you didn't turn in the assignment, or two, this is one everybody missed. Okay, so everybody should be paying attention, right? I think that would make sense. $20 is her revenue, $5 is the cost, so 20 minus 5 is $15 per share. And then here, if she loses $1, it drops to $1. Her revenue is $1 minus her cost is $5. That would be minus $4 per share. Okay? And the two probabilities are 0.1 and 0.9. Okay? So if you look at her expected outcome as far as her expected share price, then you're going to have the $15 times 0.1 minus her $4 share price times 0.9. And then whatever the result is here determines if she made a wise investment. Okay? So we're going to say 15 times 0.1 minus 4 times 0.9, and you end up losing $2.10 per share, okay? So this was not a wise investment. Okay? And that would be your conclusion. Okay? Alright, does anyone have any questions on that? So again, some of these problems, guys, they're giving you the probabilities, but you also have to be able to figure out what's my expected outcome. You know? This right here, you have to know profit is revenue minus cost. If you don't know that, you can't set up the expected outcome for the share price. Okay? So you have to know those things. Alright? Does anyone have any other questions on that? Are y'all good on that? Say again? You want to look at 18? Let's see. Let's see how y'all did on it first. Number 18. Yeah, about 15% got 18. Correct. And 20, 0. So let's look at 18. Alright, it says a bag contains 2 silver dollars and 6 slugs. So this is number 18. And you have a bag. And you have 2 silver dollars. We'll call them SD. And 6 slugs. We'll call it SL. It says a game consists of reaching into the bag and drawing a coin, which you get to keep. It says determine the fair price of playing this game, that is the price at which the player can be expected to break even if he plays the game many times. In other words, the price at which his expectation is 0. Alright. So you got 2 silver dollars and 6 slugs. Okay, a game consists of reaching into the bag and drawing a coin, which you get to keep. So we're going to assume the value is the dollar. Okay, I know it's a silver dollar. It might be worth more than the dollar amount, the face value, but we'll assume it's just $1. So we're going to look at the outcomes, and we're going to look at the probability of the outcome. The first outcome is that you reach in the bag and you pull a silver dollar. Okay, so if I pull a silver dollar, I'm getting $1. And did I pay to play? Yeah, that's what we're asked to find out. Okay, what's the fair price of playing this game? So we're going to say $1 minus the price that it cost me to play it. Okay, and then this one over here, if I pull out a slug, well, I'm just losing that amount, right? So that would be whatever the price is I paid, I lose that value. How many silver dollars are in here versus the whole bag? What's the probability of drawing a silver dollar out? It's going to be 2 out of how many coins? It's 2 out of 8, which is 1/4. And 6 out of 8 for the slugs is going to be what? This is your silver dollar and this is your slug. So what's the probability of drawing a slug? If this one's 1/4, this one would be What's 1 minus 1/4? Or I could do 6 over 8. Yeah, it's going to be 3/4. All right. So then the expected outcome is going to be the 1 minus p times 1/4. And this over here is what? It's a negative p times 3 over 4. And the expected value, if it's a fair game, is what? What's the expected value if the game is fair?
1.
Huh?
No, 0.
0. So you just set all that equal to 0. If you notice, guys, both these terms are divided by 4. So if I multiply through by 4 on both sides, I end up with what? So say I'm going to take this and take this times 4 times 4. That knocks out the denominator, so I get 1 minus p plus a negative 3p is equal to 0, because 4 times 0 is still 0. So what do I get here? I get 1 minus p plus negative 3p. That's 1 minus 4p is equal to 0. If you add 4p to both sides, you end up with 1 equals 4p. And then you just divide by 4. So you get p is equal to 0.25. So the fair price is going to be 25 cents. Which means if I pay a quarter on this game, I'm doing good. Okay? That means I can pay, I can play it, and not risk just handing someone money, because I may have a good chance of winning. I wonder what expected value is on the lottery. I don't even want to think about that.
I think the chances of the lottery are like 1 in 100.
Oh, I know. Can you imagine, though?
Which is why I just buy $137 million worth of lottery tickets.
Just take out a load.
Just take out a load.
As long as the the win is after taxes is bigger than 137.
Yes.
Fine with me.
All right,
Last
guys.
is to lose.
And then I will retire to a country that nobody's heard of, because I will owe a lot of people a lot.
See you later.
Hey, guys. Can y'all listen? On the expected value problems, there are the review problems. If you look at that textbook section, it is like right after this is review. It's got concept check, and then it's got exercises. Okay. I would look over the concept check. I'm not going to have you do those, but make sure you know what they're talking about on each of those questions. So when you're studying, I would look over that. And then the exercises, can y'all work on the odd ones? And I think that's 1 through 39, if I'm not mistaken. Yeah. 1 through 39, odd. Okay. And then we can talk about some of these tomorrow. I mean, if you got questions today, I'll answer your question, but we can talk about them as a class tomorrow. All right. Think back to everything we've done. Remember, we've done counting principles, the fundamental counting principle. We've done permutations, combinations. We've done, what is it? Distinguishable permutations. So remember those problems. I don't think binomial probability is in this set. Okay, it's not. But make sure you do these problems and be ready to talk about them tomorrow. Okay. Obviously, some are going to be expected value, which is what we were just talking about. Make sure you know how to set up a probability, know how it's defined. It's favorable outcomes over possible outcomes, which possible outcomes, that comes from your sample space, so be able to identify a sample space. If I'm rolling 2 die, or if I'm looking at a deck of cards, know what your sample space is, okay? And the last thing I wanted to do today is check your work from yesterday. Remember the binomial probabilities? Okay? Yes. Yeah, did y'all finish the calculations?
Yeah, that's what I'm doing.
Okay. No, I'm going to put the answers I got, and then if y'all got something different, how about you let me know? Okay?
Well, we're still gonna go through it.
Because I set something up. Remember yesterday I showed you how to set up the hold on, Charlie, I'm still mid-sentence.
I didn't round, I'll talk about it. I didn't round, but that's the whole.
Hey. So, Ethan. No, I set this up yesterday on a spreadsheet, which is what I told you you could do. So, if you see something that I have that you're like, I didn't get that number, let me double check mine. Don't just say, oh, I got that wrong. Let me know you're different, and we'll look at how I did it versus how you did it. Okay? All right. I got to tag y'all on attendance.
Now, I gotta go find my stuff. First sergeant's got it, and that's what we've been trying to do, find first sergeant.
What is this for? Am I signing this?
No, that's just to say I'll see what. First sergeant got my stuff. And I have no idea.
So you're here, Ethan Phipps is here. Did anyone else come in? TJ, Jody, Tony, Tinquasia, Michaela. All right. Who? She is? All right. Well, I'll have to tag her at some point. All right, guys, can y'all see this pretty good? You can't? Yeah. Let me see it. I'm locked, y'all. Let me unlock that and let me see if I can zoom it. And apparently it's not letting me zoom. Maybe because I'm recording. But let me read off the answers then if you can't see it good up here. Or if y'all want to shut the light off. Because actually both lights are on right now. And normally I do mine in pen so y'all can see it better, but this one I did in pencil, sorry. Yeah, the first one, guys, is .006. Yikes. No, that's good.
I got all mine right.
Well, that's good if you got them right. B is .212. C is .0754. D is .129. E is .0106.
Whoa. I got 0105.
You got what?
0105.
It's probably rounding.
Even if you round, it's still, because it's 37.
Okay. We'll have to look at it then. Put a tag on that one. All right. Number 2. I got .212. And then B, I got .036. C, I got .134. D, I got .435. And then E, I got .212. .212. And guys, I hope y'all realize and you notice this and saved yourself the trouble if you're listening. See this probably of X being between 5 and 7, the number of successes? The only thing between 5 and 7 is a 6. So obviously that would be the same answer as answer A. Okay? That was the shortcut on doing that problem. Okay? Is to recognize that. Number 3, A, I got .146. B, I got .526. C, I got 4.158 times 10 to the minus 4. And D, I got .221. Okay? And then 4, I got .00246. B, I got .155. C, I got .056. And D, I got .272. Okay? Number 5, I got .201 for A. B, I got .995. C, I got .866. And does someone got the answer to D? Because I don't have it. That's. I had to leave school yesterday for an eye doctor appointment, and I hadn't quite finished D.
2.385412877 negative.
Okay, what were you finding though? The probability of.
I would have to go back and refresh it. Yeah, I totally looked it up. But, I looked it up with this calculator.
Yeah, hey, Charlie, I know for a fact you looked it up.
Yeah, I looked it up with this
No,
calculator.
you did not. No, you did not.
Let's see. What is it? Is this one? So you want at least 4 do not believe in ghosts. What does that mean?
At least 4.
So the success on this, how I define it, was what? That they did believe in ghosts. So if at least 4 do not believe in ghosts, that means how many believe in ghosts? 3? So I'm looking at the probability of X being less than or equal to 3. And if I go to my spreadsheet, wherever that is, let me get back to Google Drive and try and find it. And let's see if I can find my spreadsheet I was working on yesterday. Do y'all see it? I got untitled spreadsheet, but I could have sworn I titled it. Last modified by me. I don't see it. Let's see, I do binom. Andrew Shepard. I'm pulling your stuff up. There it is right there. Okay, so how many successes am I wanting? 3? Come on, Bubba Head. 3. I'm not worried about max. Number of trials was 16. So if I want X less than or equal to that, I got .134. Is that what you got, Charlie?
No,
On the last one?
I didn't do like. Oh, now I got 2.385412877 negative 4.
Oh yeah, that's really low. And that's for 5D. Yeah, that's really low.
5D is .0002385.
Yeah, you should end up with a .134. Because again, if you're doing 4 or more don't believe in ghosts, that means you have at least or at most 4 that do. Okay? So, am I thinking about that right? You agree with that? All right. Alright. Alright, did y'all have a question on, you said 1E was questionable? We had n equal 22, x equals 20, and 0.68. So n is 22. And what was the probability? I can't see nothing. 0.68 and x is 20. So 0.68. 20. Yeah, see, I get 0.01057, Charlie, on 1E. That's what I'm getting right there.
Yeah, that's what I got. Said I need to round, I'll take it with round.
Okay.
I didn't round it up because I didn't want to do it wrong.
All right, that's fine. No, you want to round. I mean, I wouldn't write out all these digits.
To the first four, I think so.
Say again?
Round to the first four digits after the decimal.
I usually try and keep 3 numbers, like significant digits at least. You know what I'm saying? So even if it's 0.01, the first non-zero number, I'll do 3 after that, typically. Yeah. And you'll learn later, probably in college, how to deal with significant digits. You know, if you have a problem that's giving you information to 3 significant digits, then your answer can be the 3 significant digits. But you won't want to shorten that or say it's to 5 significant digits when that's not how your information is given, because it's not really accurate to that degree. But we usually don't, I guess, make students do that in high school, but you'll see that in college, especially in your sciences and stuff like that. All right. Y'all, are y'all just getting here?